Hello. In this video, we're going to go over section 1.4, which is on organizing categorical data. The first step in analyzing data is to organize the data in a way that helps us identify patterns. With categorical variables, this typically requires splitting the data into groups, then comparing how often a category appears in one group versus how often the category appears in the other. For example, suppose you had polling data on the question, should taxes go up on individuals making over $400,000 per year? You could organize this data by splitting it along political party and then determine whether one party said yes more often than the other. This type of analysis requires knowledge of percentages and rates, so you may want to go through and do some background research on those topics before proceeding. The two-way table is a tool for organizing categorical data. It compares how often two categories appear in a data set that is split into two groups. To construct a two-way table from individual data, count up how often each category appears for each group, then present the results in a 2x2 table. That's why we call it a two-way table. The number of times that a category appears is called the frequency. Once categorical data is presented in a two-way table, it can be analyzed on a percentage or a rate basis to determine the relative amount that a category occurs in each group. Let's look at an example. All right, so on the left here, we have individual data. Okay, so the individual data is broken up where we have one column has male. All right, so that tells us the gender of the individual. So the ones would be true. The ones would be true for being male. All right, so those are going to be the men, and the zeros are going to be false for male. So they're going to be the opposite of being male, which is female. All right, and then for the not always column, we're going to have these are people who do not always wear their seatbelts. So that's the context. And the ones would be people who do not always wear their seatbelts. So like the first two here do not always wear their seatbelts. And then here we have three that do not always wear their seatbelts. And then the zeros would be the opposite. They'd be false to not always wear their seatbelts. So that means that they do always wear their seatbelt. Okay, so to go through and construct the two-way table, what we want to do is count up the number of times that the genders appear for each group, right? And the group in this case are not always versus always. And then we put it into the 2x2 table. I think you can see the 2x2 table here at the bottom. Okay, so we start off with not always. That's our first group. And then we want to count up how many men there are in the not always group. So to do that, you're going to look to your not always column. You're going to find the places where that's true, because that's what we're looking at. We're looking at people who do not always wear their seatbelts. And so we have these first two are true, and then we have three more that are true down below. And the first two, these are both men. So that gives us two men who do not always wear their seatbelts. These three do not have one, so those are not men. So we're not going to count those just yet. All right, so we have two men who do not always wear their seatbelts. And so we put two next to the not always row below the male column. All right, and then we want to go through and do that for female. So we've got not always. Again, you want to go to the not always column, find where that's true. But now we're looking for places where the male column has a zero. Those are going to be our females. All right, so we've got three of those, so that we've got three females who do not always wear their seatbelt. And next we go to always. All right, so always, those are going to be places where we get zero in the not always column. Again, so it's going to be false for not always. That's going to give us always. And so we've got three men who always wear their seatbelts, and then seven women. All right, so we want to put three men, always wear their seatbelts, and then seven women. All right, so that's how we go through and construct a two-way table from our individual data. Next, we want to go through and analyze the two-way table. So here we've got our two-way table. How can we go through and analyze this? All right, it's tempting to go through and just compare the raw numbers that are in the table, but that's not accurate. Okay, why not? The reason is that you could have different numbers of men and women. So you can't go through and look at this and say, oh, there's two men who do not always wear their seatbelts. There's three women who do not always wear their seatbelts. Thus, the women are more likely to not always wear their seatbelts. Now, it doesn't work that way. And the issue is that you could have more women than men, and the number of women could end up overwhelming the fact that we've got 3 here. Okay, so to go through and do the comparison, what we need to do is we need to convert these numbers into percentages. Once they're percentages or ratios, we can go through and we can directly compare them and be able to draw conclusions. All right, so to do that, you need to go through and figure out how many men there are and how many women there are. That's the first step. So to do that, we go through and add 2 and 3. That gives us 5. And then we add 3 and 7. That gives us 10. So we've got 5 men, 10 women. And then we want to take these 4 entries and divide them by the total, for their column. So we take the 2, divide it by the 5, and that gives us 40%. And we take the 3, divide it by the 5, and that gives us 60%. So that tells us that 40% of the men do not always wear their seatbelts, and 60% of the men do always wear their seatbelts. Same thing for the women. We want to take the 3, divide it by the total, which was 10. 3 over 10 gives us 30%, and then take the 7, divide it by the 10, and that gives us 70%. So what we have is we have 30% of the women do not always wear their seatbelts, and 70% of the women do always wear their seatbelts. And then so we can go through and directly compare the percentages. Through that direct comparison, we can see that men wear seatbelts less often, since 40% don't always wear their seatbelts versus 30% don't always wear their seatbelts for women. Okay, so in the previous example, we went through and started off with a frequency and a total, and then we divided them to create a percent. All right, so we created a percent given the other 2 pieces of information. Sometimes we start with a percent and we want to go through and find either the total or the frequency. So we want to go the other way. All right, so if you have the percent and the total, then you multiply to find the frequency. If you have the percent and the frequency, then you divide the frequency by the percent to find the total. All right, so the 3 cases derive from this formula. Percent equals frequency over total. Okay, so that's kind of the default, and that's the one that we did on the previous page. So you've got percent by itself, and you take frequency over total to find it. All right, so using algebra, you could go through and you could solve for frequency. If you solve for frequency, then you'll end up getting percent times total, which is the first case here. Alternatively, you could solve for total. If you solve for total, you'll end up getting frequency divided by percent. All right, and that's this case here. Okay, so those are the 3 possibilities, and they each have to do with going through and getting one of these 3 things by itself. All right, so let's go through and use that to do a problem. So a statistics class has 300 students, and they are asked whether they always ride or drive with a seatbelt on. Suppose 30% of the students do not wear a seatbelt. How many students would this be out of 300 students? All right, so to go through and find the frequency given the total and the percent, you multiply the total by the percent, and that gets you the frequency. So 300 times 30% is 90. So 90 students do not wear their seatbelt. Suppose in a different class, 20% of the students do not always wear seatbelts, and then this is equal to 43 students. And what you want to do is you want to go through and find how many students are in the class. So in this case, you're given the percent and the frequency, and you're trying to go through and find the total. In that case, that's the third case, we go through and we take the frequency and we divide by the percent. All right, and that gets us the total. So 43 divided by 20% equals 215. And so that tells us the total number of students in the class is 215. All right, so let's go through and do a homework example that is similar to the last 2 cases that we just did. All right, so suppose we have a survey of men's and women's hands to see if the ring finger is longer than the index finger. Yes means that the ring finger is longer, and no means the ring finger appears to be shorter or the same length. The students in this survey were told the theory that men are more likely to have a longer ring finger than women because of additional testosterone. So a 2A table has already been constructed, so you don't need to go through the individual data to create it. Instead, you're just asked to directly go to doing the comparison by converting this to percents. So we want to go through and find what percent of the men said no, what percent of the women said no, what percent of the people who said no were men? And then if 400 men had the same rate of response as the men in the sample, how many of the 400 would say no? So those are the 4 questions we want to answer. All right, so how do we do that? So the next page has the solution, but let's talk through it first. All right, so to go through and find the percent of men said no, we need to first find the total number of men. So to do that, you want to add these two. So 21 plus 4 gets us 25. And then you want to take the no entry here, 4, and divide it by 25. Okay, so we'll just remember that, set that aside. We'll see if that's right on the next page. What percent of the women said no? So to go through and figure that out, first you need to find the total number of women. So you take 14 and 16 and then add them. So that's going to give us 30. Then we want to take the number of women who said no, which is 16, and divide it by 30. Okay, so again, set that aside, see if that's not right on the next page. And then what percent of the people who said no were men? So to calculate that, what we need to do is we need to go through and add up across the no column. All right, so it's telling us to go through what percent of the people who said no were men. We need to know how many people said no. So you want to add here across the row. So 20 total people said no. And then what percent were men? You want to take the number of men and then divide by the total number of people who said no. And then in the last case, if 400 men had the same rate of response as in the sample, how many of the 400 would say no? So to do that, we need to first go through and do part A, which is to find the percent of the men who said no. Once we have that percent, all right, so then we've got the percent, we've got the total, and then to find the frequency, you multiply the two. Okay, so let's take a look at the next page. All right, so there were 25 total men, 4 said no, 4 over 25 is 16%. There were 30 total women, 16 said no, 16 over 30 is 53%. There were 20 total no answers, 4 were men, so 4 out of 20, that would be 20%. And then given 400 men, where 16%, that's our first answer, said no, the number of men who said no would be 64. So can we draw any conclusions from these results? Well, let's go back to the question here. So a survey was done to see if the ring finger appeared longer. Yes means the ring finger was longer, and no means that it wasn't. All right, and the students were told the theory, men are more likely to have a longer ring finger than yes. So yes means that the men were more likely to have a longer ring finger. So what we're looking at is if there were more yeses for men than there were for women, then it would corroborate the theory here. Okay, now we didn't go through and find yeses. We found no's in our answers here. But you could go through and just find the opposite, by taking the number and subtracting it from 100%. Right. So this would tell us that if 16% said no, then 84% said yes. And if 53% said no for women, then 47% said yes. So 84 is significantly higher than 47. So it does look like, it does corroborate the theory that a significantly higher percentage of the men said yes, that they do have a longer ring finger. And so it does appear that the theory is true. Men are more likely to have longer ring fingers than women. All right, let's change gears here and look at a different type of problem. Suppose we're given the table below, and we want to find the city where a person would be most likely to suffer a burglary. Okay, so you've got your table here, it's got the cities, and it's got the number of burglaries. Can we go through and just pick out the city that is the most likely, where you'd be the most likely to suffer a burglary just by looking at the number of burglaries? The answer is no, you can't. The issue is that the cities are different sizes. If these cities all had the exact same amount of population, had the exact same size, then yes, you could just look at the number of burglaries and make that determination. But Houston could be different size from Memphis, and that size difference could explain the difference between the two. So if Memphis is a lot smaller than Houston, then the number of burglaries being different between the two of them could be explained by the size difference, right? Okay, so we need to go through and adjust for that size difference. How do we do that? Well, we need a measure of size, okay, to be able to do that. And so the easiest thing to do would just be to use population. All right, so if we go through and add population into the table, now we've got population and the number of burglaries. And so between the two, you could try and make an adjustment. Okay, so we could see here, for example, that Houston is almost 4 times the size that Memphis is. So the fact that it has twice as many burglaries does make sense. It makes sense that it had more burglaries because it is so much larger. Okay, so to go through and try and adjust for the difference between these, what we can do is we can take the number of burglaries and we can divide by the population to get a per capita amount of burglaries. And by using that adjustment, it would enable us to go through and see more clearly what the differences are in the data. Okay, and so here we've gone through and done that. The one additional thing that we've gone through and done is that we've multiplied by 1,000. So instead of finding the burglaries per capita, per person, we're finding the burglaries per 1,000 people. Okay, so that's, why would you do that? Well, if the result is really small, then you multiply by 1,000 so that to kind of adjust for that. So if not for that, this would be 0.008, 0.004, 0.009. They'd be really tiny numbers, and so it's just easier to do the comparison if we go through and multiply by 1,000 and find the number of burglaries per 1,000 residents as opposed to the number of burglaries per person. Pardon me. So if we look at this, once that's done, we can then go through and do a direct comparison. So this is like the percents were in the two-way table. So once you've gone through and adjusted for the size, then with that you can do a direct comparison. And in so doing, what we can see is we can see that Memphis actually, even though it had the smallest number of burglaries, is actually the place where you'd be most likely to suffer a burglary. And it's just because Memphis has a very small number of burglaries relative to these other cities, but it's a lot smaller. And so because of that size difference, the size difference more than makes up for the differences in the number of burglaries. Okay, so let's look at a homework example that is somewhat similar to that, and we can go through and practice. All right, so the accompanying table gives us the population of 6 regions in 2008 and the area of those regions. Find the population density for the 6 regions, then rank them. All right, so how do we go through and find population density? So population density is the population per unit area, or the population per area. So what we want to do is we want to take the population and we want to divide by the area. And if we do that, then it will enable us to go through and find the population density for these places. So we want to take this number and divide by this number. All right. So here we've done that on the next page. So if you go through, take 12 million for this region, divide by 42,000, you get a population density of 293.46. So that's the number of people per square mile. Okay, that's how population density works. And then once we've done that, we can then go through and rank the places. And so we could see that the place that has the lowest population density is region E. Oh, sorry, region D. And then that's the highest. Okay, so whoops, the population density for region E is the lowest, and the population density for region D is the highest. Okay, and then we can go through and just rank them by comparing the numbers from there. Okay, so that's the video. Thank you for watching. I'll see you next time. Bye-bye.